Hello everyone, good evening. Is my screen visible to you and am I audible? Is my voice audible? Good evening, Tarun. So in the last few sessions, we talked about different aspects of electricity chapter. For example, we started with why electricity is so very necessary for the science students, especially the physics students. Sorry. And what are the various ways in by which electricity is being produced, stored, and transferred to different places? What are the various significant aspects related to electricity chapter? For example, we have understood about electric current, charges, we have talked about potential difference, electric power, and so many other things. So later on we understood about the concept of resistance, how resistance is being calculated, and what are the major parameters which are involved in calculating the resistance, or which are the main dominant parameters for changing the value of resistance. Now in today's session, what we are going to do is we will be calculating different aspects of what this just give me a minute. My voice is audible, no? Okay, so today we will be talking about the connections of these resistances in series and parallel, depending on the requirement and what formulations are required for that. So we will be understanding these combination of resistance. So we have two options with us. One is the series circuits like these. So in series circuit, what is going to happen? The two resistances or the two devices will be connected end to end with each other. For example, if one device is connected in this point, so second device will be connected after the first one is ending. This will be, these types of circuits will be known as series circuits. But when parallel connections are required, so parallel connections, both connections will be connected to the same terminal, and both the connection will be ending towards the same terminal. So these will be known as parallel combinations. We will be understanding about these more in the next slides. So in series connection, when multiple resistances are connected in series, as we discussed in the previous slide, then what is going to happen? How the value of resistance, because we have already understood about Ohm's law, V is equal to IR, we already know about it. So when these devices would be connected in series, so what is going to happen? Each resistance will be having a different potential difference across its end. What does it mean? Let us see in the circuit. This is a circuit, a very simple circuit. The voltage of the battery is V volts, and the net current is going to be I, capital I, and net resistance will be capital R, and net voltage will be capital V, which would be the voltage of the battery. So in R1 resistance, current will be I. Why is it so? Because same current is flowing through each resistance. This is the property of series connection. And what will happen? Different values of potential difference will be coming across different value of resistances. So can we derive this thing also? So yes, there are some formulations. So initially, can we what we can do? We can just write it down that the value of I would be same, and the value of V would be V1 plus V2. This is our notation number 1, based on the value of resistances. Now what is going to happen? We already know that the value of net resistance and net circuit would be is equal to V is equal to capital I into R. Now formulating these values further, V1 would be equal to I into R1, because the value of I is going to be same, and V2 is equal to capital I into capital R2. Now formulating these values into the formula, these three values 1, 2 and 3 into this formula, what will happen? Capital IR is equal to capital I into R1 plus capital I into R2, and capital IR is equal to capital I into, I am taking I as common, R1 plus R2, so I will be cancelling out. So net resistance in series circuits will come out to be R is equal to R1 plus R2 plus so on. So these will be the value of series circuits. Now coming to the one example for this, a very simple example. So what is mentioned, if four resistances each with a value of 1 ohm are connected in series, so what is going to be the net resultant value? Very simple. Okay, so this was very simple. We already know that if four resistances are connected in series, so this will be the circuit, 1 ohm each. So net resistance would be R1 plus R2 plus R3 plus R4, that is 1 plus 1 plus 1 plus 1, and the answer would be 4 ohms. Very simple question. Moving on to the next question. A resistance of 6 ohm is connected in series with another resistance of 4 ohms. There is a connection of two resistances. A potential difference of 20 volts is applied across the combination. So we already know the value of potential difference as well. So what are we supposed to calculate? We need to calculate the current throughout the circuit. That is number one question. And second, we need to answer this question, that what would be the potential difference across 6 ohm resistance. Two parts of question are there. Tarun, can you please try again? This value is not correct. The value of current is not correct. Mohini, the value of current is not correct. I think there would be some calculation mistake which could be corrected. Let us draw the circuit. So two resistances are there. One is 6 ohms and second is 4 ohms, and they are connected in series, and there is a battery of 20 volts. Yes, Tarun, I think current's value is correct now. Let us also find it out. So first of all, what we are supposed to do is we need to find the value of total resistance. We know that in series circuit the resistance is equal to, net resistance is equal to the, just adding these values down. So 6 plus 4, that is equal to 10 ohms. V is already known to us, 20 volts. So the value of net current would be V over R, that is 20 by 10, 2 amperes. So 2 amperes would be the value of first option. So we have already completed the first part, this part. So now we are supposed to calculate the potential difference across 6 ohm. We know that in series combination we have equal currents but different values of potential difference across different resistors. Yes, Sweta, this is correct. Mohini, have you understood this value? How the value 2 amperes is coming? Now please proceed to the second part, which is the most important part. To calculate the potential difference across a single resistor. Yes guys, what would be the value? See, we already know that current's value is going to be the same, which is I is equal to 2 amperes, plus we already know the value of resistance, which is 6 ohms. Now with the help of our formula of the Ohm's law, V is equal to IR, we are going to calculate the value of V1. Putting these values together, 2 into 6, 12 volts. So this value is going to be 12 volts. Is that correct? Now it has not mentioned in the question. If the questionnaire would be asking us what would be the value of voltage across 4 ohm resistor. So now there could be two methods. The method number one would be simple method. I is going to be the same. V2 we have to calculate. R2 is going to be 4 ohms. Putting these values together, so 2 into 4, that is equal to 8 volts. There is another method also, but that would be applicable if just two resistances are there. So net V is going to be the V1 plus V2. है ना. So accordingly we can have this value. Now please move to the next question. Please find this value as well. So there is a 6-volt battery which is connected across a lamp whose resistance is given to us as 20 ohms, and the current or the net current of the circuit is 0.25 amperes. Now we have to calculate the resistance from the resistor which must be used. So first of all, is this question understood to all of you? By the way, the language of question is completely same. This was asked as it is. So in this question, what is being asked, that there were apart from lamp, there was another resistance whose value we are supposed to find. Yes, Tarun, your answer is absolutely correct. So the value of R is given to us, or we can say it R lamp is given to us as 20 ohms, and the value of current is given to us 0.25 amperes. Now with the help of, and we already know one value more, we know the value of V as well. So V is given to us as 6 volts. So can we find, by these two values, can we find the value of net resistance? Yes. So we know the formula, V is equal to IR, and R is going to be V over I, and V is 6 volts and I is 0.25, which can be written as 1 by 4. So net resistance is going to be 24 ohms. Okay, so net resistance has been arrived to. So now moving backwards to this question to understand how this question is being applied. There was a circuit with a lamp connected to it, and there was another resistance which is unknown to us. So we can write it as R unknown. The resistance of RL was 20 ohms. This is not known to us, but the net resistance was 24 ohms. So we know that in series circuits, the value of this is going to be 20 plus R is equal to 24. So the value of R, which is unknown, is going to be 4 ohms. Understood? This question is generally not asked directly. This is an indirect question. So now moving to the next question, which is from your NCERT book. We have to draw a circuit diagram which consists of 3 cells of 2 volt each. Resistors are given and other aspects are also given. So this is the first part. Now again we have to redraw this circuit with the help of ammeter and voltmeter according to the question. So please kindly proceed with the question. This is a type of question which is being asked in your CBSE board exams and other board exams also. Sometimes some readings are provided to us of ammeter or voltmeter, and based on that they structure a new question for you. Sometimes the question is being asked with the help of you drawing a diagram and then explaining the entire things. Yes, Tarun, the measurement is absolutely correct. Let me just draw the diagram for you. So this was the initial diagram. Now we are just redrawing this with ammeter and voltmeter. Voltmeter connected across 12 ohm resistor. Okay, so now initially we will be calculating the value of I. Yes, voltmeter value is also correct. Thank you, Tarun. R net we can calculate with the help of 5 plus 8 plus 12. So this will be 25 ohms. V is already known to us as 6 volts. I value is going to be V over R, and this will be 6 over 25, 0.24 amperes. This will be the reading of ammeter. Now what will be the reading of voltmeter connected across 12 volt 12 volt 12 ohm resistor. So resistance is 12 ohm and current is 0.24 amperes. So V is equal to IR, so we will be multiplying these together and this will come out to be something near to 2.9 volts. Okay, so let us move to the next. Now coming to the parallel combination, because series combination are very easy. We already know simple plus and minus is required. So now coming to the parallel combination. First of all, we need to understand the parameters or the characteristics of a parallel combination. Related to the potential difference, the potential is difference across all the resistance is going to be the same. You can see in the circuit that V is going to be the same. Across R1 it is going to be the V, R2 also V, R3 also V, and the value of current is going to differ. And how is it going to differ? The value of net current would be equal to the summation of all three values. And I am not going into the derivation, I am just putting the value as it is so that we can come with a few numericals. So 1 over R equivalent, or that will be the equivalent value in parallel, is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this will be the net value of our resistances across parallel combination. Now moving to a very simple numerical, just to warm up you. We need to calculate the equivalent resistance when two resistances of 3 ohm and 6 ohm are connected in parallel. Thank you for the answer, Madhu. Thank you for the answer, Tarun. Okay, so let us just calculate this. We already know the formula. 1 over R equivalent is going to be 1 over 3 plus 1 over 6. Taking LCM as 6, so the value here would be 2 plus 1. So net value is going to be 3 over 6, which is 1 by 2. So the value of 1 over R equivalent is equal to 1 by 2. Reciprocating these two, we can get the value of R equivalent is equal to 2 ohms. So net resistance is going to be 2 ohms. So Tarun, you need to again calculate this and please identify your mistake. Now moving on to the next question, which is going to be little difficult than this question or more complicated than this. So here what we can find, there is a circuit diagram with 3 resistances. First of all, we need to identify the total resistance of the circuit. Second, we have to identify the total current that will be flowing through this circuit. And then we also need to understand what is going to be the value of potential difference across R1. You can also calculate the potential difference across other resistances as well, that is R2 and R3. this is the type of questions which are being asked. And let me remind you, this is one of the most important questions for your examination point of view. And I have lots and lots of questions for you, even more complicated than this. Yes, can we have the value of resistance, the total resistance? By the way, this is also the sequence in which we are supposed to answer the question. First of all, we need to find the common values, there is total resistance or total current. After that, once we are having the value of these things, then we can going into the individual value of potential difference across a single or multiple resistors. Tarun, I think the value of current is incorrect, and Madhu, I think the value of resistance, net resistance, is also incorrect. Let me just provide you with a hint, a very simple hint. Let us forget everything about the circuit, just we are going to concentrate on the value of resistances or the connections between these resistances. So there are three resistances connected like this. This is 7.2 and this is 8 and this is 12. So our target is very simple. Let us first of all understand how we are going to simplify this thing. Madhu, this value is also incorrect. So beta, what we can do? First of all, let us solve the value of this parallel combination. For example, let us take a few examples also. I think before solving this question, let me come up with a few examples. We can just skip this part, or okay, just ignore the question. Madhu, this is also incorrect. No, I think 12 ohm might be correct. If this is a circuit, all the values are 1 ohm and these two values are 2 ohm. So how are we going to calculate or simplify this thing? Initially, what we can do, we can solve these three values and this value we can solve. After that, once we are getting with these values, then we can carry over forward. So the value is going to be, these three are in series, these three. So 1 plus 1 plus 1, that is 3 ohm. So equivalent would be 3 ohms. And these two are in parallel, these two. So 1 by 2 plus 1 by 2, that is 2 as LCM, 1 plus 1. So this will 2 over 2. So 1 ohm would be the net resistance. So the answer would be 1 ohm. And last resistance was 1 ohm. So outcome is going to be the combination of these. So we have solved what we have done. We have solved the value of individual resistors which were directly connected in series. The step number 1. Then what we have done, we have solved the values of individual resistors which were connected in parallel. The step number 2. After that, once we have got these values, then we have simplified the entire circuit or solved the entire circuit of series combination. Now coming again to our question, first step would be to solve the value of these two. 1 by 8 plus 1 by 12, LCM would be 24. So the value is going to be 5 over 24. So nobody has given this value, and this will be 1 over R. So R is going to be 24 by 5, and this is going to be 4.8 ohms. This is the value of R resistance for this. Now simplifying and putting these values, this was 7.2 ohms and this is 4.8 ohms. So net resistance is going to be simple addition of these two values. So the outcome is going to be, the net resistance is going to be 12 ohms. So yes, Madhu, the answer from you was correct. But I think it was after so many efforts. Okay, so now you can calculate the value of total current. Net resistance is known to us, net voltage is known to us, so the net value of current would be very easy to find out. And by the way, Madhu, the answer is absolutely correct. So what we are already having, R net is known to us, which is 12 volts, 12 ohms, and voltage is 6 volts. So I is going to be V by R, 6 by 12, 0.5 amperes. Are you guys with me? Have we all understood this concept? We already knew the value of resistance, net resistance, voltage was provided to us. So the value of current or the net current flowing through this circuit is very easy to find out. Now moving to the best part of this question, potential difference across R1. Thank you for your answer, Tarun. Thank you for the answer, Madhu. Okay, so let us understand this question. First of all, let us just have a quick recap of the concept. In a series combination, the value of current was same across different resistors. In a series combination, the value of current was same across different resistances. For example, if it was being asked to us that what would be the value of current in R1 and in R2, so we would say that the value is going to be I. A simple thing which is being understood. But in a series combination, the value across a resistance for the potential difference is going to be different. I think I have made this complicated. So what I really want to say is the value of potential difference across R1 is going to be V1, which is a different value, and across R2 it is going to be V2. And one more interesting thing, the value of capital V, which is the voltage across the entire circuit, is going to be a combination of V1 plus V2 or other values as well. Similar would be the case in parallel combination, but there would be voltage is going to be same and current is going to be the combination of different values. So with this principle, initially one thing is understood to us, that if the value of current, whatever it might be, the value of current would be same in this and across R1 resistor, and value of current is going to be same RP is this combination, the solution of this combination. So across RP also the value of current is going to be the same. Now solving these values, let me just remove everything. But we are supposed to calculate the potential difference across this resistance. So we already know the value of resistance R1 7.2 ohms, and the value of current is known to us, which was 0.5 amperes. Now solving these values together, V1 is equal to I into R1, that is I into 7.2, which is 3.6 volts. Now calculating the values for R2 and R3 as well. Now this is a tricky question. What trick has to be, this was easy, the value across R1 was easy. Across R2 and R3, the potential difference, we know that the value of potential difference is going to be the same, whatever the value would be, but it is going to be the same. Why is it so? Because they are connected in parallel, but the value of currents would be different. So there are many options to perform this thing. One option, which is the easiest, let us make this as value V2, and we already know that V is equal to V1 plus V2. So the value of V is given to us as 6 volts. The value of V1 we have already calculated as 3.6. So remaining V2 would be 2.4 volts. So this 2.4 is going to be across R2 resistor and across R3 resistor. So whenever it would be asked to you, what is going to be the value across two parallel resistors, the value is going to be the same. Now moving on to the next question. I'm skipping this question as of now. You can take a screenshot and you can use this question as your homework. Moving on to the next question, which is one of my favorite questions. So a circuit is given to us. Simple circuit. I don't know if you are founding it complicated or what, but this is a very simple circuit with 4 resistances connected in the circuit combination, and these are the things which we are supposed to answer. First of all, we need to find out the value of total resistance, total current, these currents, and these potential differences. This delta is known as potential difference. So potential difference is also always calculated across 2 points. That is why delta is mentioned. So what you will be answers you guys can provide me by stating RT, I1, I2 in these very formats. Let me give you one very simple trick which could be used in this question. Whenever there would be multiple resistors connected in parallel and the resistors would be same. For example, in this case, there are 2 resistances, 8 ohms, 8 ohms, and they are connected in parallel, and the values of both the resistances are same. So what we can do, we can simply put the value of resistance which was being given to us, and we can divide by number of resistances, which in this case is going to be 2. Let me again provide you the formulation for this. Madhu, your answer is correct. For example, if 4 resistors are provided over here with the same resistance R, so answer is going to be R, which is the resistance of a single resistor, and total number of resistances, which is going to be 4. So this is our simple formulation for this. This could be very helpful in your this 10th class as well, and in your upcoming classes as well. So solving this value would be 5 ohms, 4 ohms and 6 ohms, which is 15 ohms. So this value is going to be 15 ohms. No, Tarun, the value is incorrect. First of all, Tarun, please find out the value of total current. These type of questions are only possible if we are going to be moving towards them stepwise. Very impressive, Madhu. All the values are absolutely correct. Yes, all are in amperes. Thank you so much. Yes, Tarun, the net value of current is absolutely correct. So it is going to be 4 amperes. Let us also calculate this value. So we know the value of V, which is 60 volts, and the net value of resistance. So net value of current is 4 amperes. Now from the circuit itself, we know that the value of I over here and the I over here, these two, that is R1 and R4, are going to be the same as the net current in the circuit. So these will be 4 amperes and 4 amperes. And what about these two values, I2 and I3? Okay, most of the answers are correct. So now calculating these values together, we already know the value of total resistance, total current is known to us. By this circuit, we already know this value I1 and I4. So we have put these values together. Now when this current is going to be here in this circuit, the value is going to be 4 amperes, and here also the value is going to be 4 amperes. So this current is dividing into two parts, and the values are going to be 2 amperes and 2 amperes each. Now moving on to the voltages or the potential differences. Potential difference is easy to find out. Delta V1 is going to be I1 into R1. Just putting these values together, I1 is 4 ampere and R1 is 5, which is 20 volts. This is I2 into R2, I3 into R3 and I4 into R4. So these values will be, I2 is 2 amperes and R2 is 8, so this will be 16 volts. I3 is again 2 amperes and R3 is again 8 volts, so this will be 16 volts as well, and this will be 4 into 6, so the value would be 24 volts. Now if we can make a summation of these together, so summation would be like, not these together, just three things. One, the combination of this and this, so it will come out to be 60 volts, which is the case in which we have started these values. So these type of questions are being asked in your examinations, and anything could be asked. For example, the potential difference across a single resistor could be asked, across multiple resistors could be asked. So these type of questions are generally provided in the examination. So in the next class also we would be just entering into few questions, few difficult questions related to these, and later on we would be covering about the electric power and power consumption and how the units are being calculated, how the total number of total value in rupees of our consumption is being calculated. So we will be asking those type of questions as well. So till then, thank you so much, and hope you like this session, and take care. Bye. Madhu, why you are getting 76 volts? Because you have calculated the 16 volts 2 times. We know that it was connected across 2 resistors, and value is going to be the same. So we would be calculating as 20 volts, one time 16 volts and one time 24 volts. This is how the values are going to be calculated for the net value of potential difference. Okay guys, thank you so much. Good night, take care, bye bye.